Welcome to the feedback video of week 2 and the introduction of week 3. We are now in front of the Reactor Institute of Delft University of Technology. Today we will be asking Professor Jan Leen Kloosterman to elaborate on the questions that he asked on the end of his videos. Please join us as we go in. We're here at Professor Jan Leen Kloosterman's office at the Reactor Institute of Delft. Jan Leen, good to be here.
Yeah, welcome here at the Institute.
You asked us a couple of questions in the last few videos, and one of which was the theoretical maximum value for the reactivity.
Aha, yes. And I don't know how many students thought about it, if there was a discussion going on. Now let me explain what I meant with the question. If you have reactivity, we know that the reactivity is the k minus 1 divided by the k, where k is the multiplication factor. So for an infinitely large reactor we have k infinite minus 1 divided by k infinite. And k infinite we know is nu sigma f divided by sigma a. So this is nu sigma f divided by sigma a minus 1 divided by nu sigma f divided by sigma a. So this is nu sigma f minus sigma a divided by nu sigma f. Well, what is now the maximum value? We know that the absorption cross-section equals the sum of the fission cross-section and the capture cross-section. The maximum value is, of course, if the capture cross-section is 0. And then this becomes nu minus 1 divided by nu. And nu is the number of neutrons, the average number of neutrons per fission. We know for uranium-235 this is about 2.45 to be more exact. So this is approximately 1.45 divided by 2.45 for uranium-235.
Okay.
And every fissile isotope has its own value. Plutonium-239 gives a little bit more neutrons, so that the reactivity will be a bit higher.
And that's because it has a higher value of nu.
Yes, correct.
Yeah. Thank you.
You're welcome.
Then there were some more questions that you asked, and one was regarding the amount of uranium-235 fissioned every day in the hoger onderwijsreactor.
Oh yes, that was a nice question. Were there some answers? Do you know if some people had correct answers or not?
Someone suggested it would be around 2 grams. Some suggested it would be around 2 milligrams.
Okay, well let's do the calc then.
Yeah.
We know what the answer is. So I will give the answer in black. So we know that 1 gram of uranium-235 corresponds to number of Avogadro divided by the atomic number of atoms. So this is 6 10 to the 23 divided by 235 atoms. If you fission every uranium-235 atom in this amount, you have Na divided by A times the average energy per fission given in electron volt times the conversion of joule to electron volt E, and then you have the amount of energy released if you fission completely 1 gram of uranium. So this is 6 times 10 to the 23 divided by 235 times 200 mega electron volt per fission, so that's 200 times 10 to the 6 electron volt times number of joule per electron volt, that's 1.6 10 minus 19. So this is the number of atoms. This number is has a unit electron volt, and this number has a unit joule per electron volt. So this is the energy in 1 gram of uranium. now we have to convert it to megawatt day units. And the megawatt day is the amount of energy released during a day. So if this amount of energy, 1 gram, is released during a day, you have to convert by the number of, you have to divide by the number of seconds a day. So that means that the energy then becomes this amount. Let me first calculate on my calculator what this is. 23 divided by 235 times 200E6 times 1.619 minus. So this is 1.2 10 to the 10th joule. So we have to divide this number by the number of seconds a day. So divided by 24 hours times 60 minutes an hour times 60 seconds a minute. So this is, let me use the calculator again. Do it otherwise. 0.95 10 to the 6 watt per day. So this is 0.95 megawatt day. Our reactor, the HOR reactor in Delft, has a power of 2 megawatt. So if it operates for 1 day, it means the energy released is 2 megawatt day. So that means that you would have to fission approximately 2 grams of uranium.
So the person who said 2 grams was correct.
Yes,
Yeah.
That's on, well, yeah, you see it's not fully correct. It would be 2.1 gram or so, but a rule of thumb is 1 megawatt day is 1 gram of uranium fissioned.
Okay, thank you. Okay, so I hope this was helpful for you. This week's content will be less mathematically intensive and more conceptual than last week's. The hardest part is already behind us. This week we will introduce you to the layout of the power plant, concepts of control and dynamics, and safety fundamentals. And we will also analyze the accident at the Fukushima power plant in Japan. We'd also like to make an announcement. During the next couple of weeks, you will still have the opportunity to hand in your answers to the assignments of week 1 and week 2. You can do this until the 30th of November. Good luck with the rest of the week.